Hi students, welcome back. So we are going to start cells of current electricity today. So regarding cells when we study, okay, we will be studying about EMF, electromotive force, then internal resistance. Then one more topic is associated with this, that is nothing but terminal voltage. Okay, so this is the topic for today's discussion. Okay, so we will start with the cells. We should have a proper understanding what is a cell. Okay, once if we understand cell, then further things will be discussed. Okay, so regarding cell is nothing but a source of energy. Okay, cell is a source of energy. So we do have a thought, okay, many students used to think like a cell is a source of charge. Okay, cell is not a source of charge. Okay, first we should clear that misunderstanding. Okay, so just you can write like, okay, note it down. Cell is not a source of charge. Okay, point by point we will analyze. Not a source of charge. Okay, so charge can neither be created nor be destroyed. We have studied that no charges can neither be created nor be destroyed also. Okay, right. So cell doesn't give us a charge. Okay, what cell is doing is cell is a source of energy. So what a cell is doing in electric circuit, all these things we will see in today's lecture. Okay, so say for example if we consider cell, okay, this is point number 1, and in between this note you need to remember point number 2 is nothing but, regarding cell it is another definition. Cell is a device. Cell is a device which provides, okay, which provides electrical energy, okay, electrical energy to all circuit elements, to all circuit elements. Okay, cell is a device which provides electrical energy to all circuit elements. When I say this, what are circuit elements? Just like whether if it is TV or fan or light, so for all these cell provides energy. Okay, now how cell is represented? This is cell is represented like this. One is positive terminal, another is negative terminal. So what this cell does? Okay, cell only circulates the charge. Cell only circulate the charge, nothing but electron. Okay, cell doesn't create any charge. Okay, what cell does is it will make the electron to move or move around the circuit. Okay, cell makes the electrons to move around the circuit. So that is why we say cell only circulates the charge. It doesn't what doesn't make any charge. Say for example if we take a circuit like this, okay, if this is a cell, okay, this is a cell and a resistor is connected across this. Now this is positive terminal, this is negative terminal. Okay, so from negative terminal, okay, cell will get energy, and cell will electrons will get energy and electrons will start moving. Okay, electrons will start moving in this direction. You have seen, okay, in this direction. So what happens to current? Current will be moving in the opposite direction. Okay, so this cell makes the electron to move. Okay, go electron, go through the circuit. It will make it circulate through the circuit. Okay, it will make the electrons to circulate through the circuit. So this is the work of a cell. It will give energy to the electrons. Okay, fine. Okay, so there are free electrons that are present in the wire and electrodes, electrolyte. So when we tell about cell, inside the cell there are electrodes and there is an electrolyte. So free electrons will be there in this wire everywhere. So cell just make these electrons to move. Okay, so and we have, suppose when we keep a resistance like this, and when we mark a cell, this resistance, when we study, we just consider them as resistance and we solve. Normally these resistances are nothing but appliances. Okay, say for example this could be bulb. Okay, this could be a fan, likewise. So this is nothing but, if we consider a cell, okay, just if we draw a bulb like this is nothing but a resistance. Okay, so these are the electric appliances. Okay, okay, so this is the point. Another point is, okay, cell maintains cell maintains a potential difference, a potential difference which force the charge, that is electrons to move in the circuit. Okay, so this, what this cell does, this cell will create a potential difference across the circuit, and this potential difference will force the electron to move along the circuit. That is what is happening with the cell and the charges. Okay, so this makes a potential difference. Suppose if we see, this is a terminal and this is negative, lower voltage. Here this point, this is at a lower voltage or lower potential we can say, and this is at a higher voltage, or we can say higher potential. Okay, one side it is at a lower voltage and the other side is at a higher voltage. So generally what will happen, electrons will move from lower voltage to higher voltage. So this potential difference will be created by this cell. Now what is a cell? This is the purpose of the cell. What is the cell? This cell is nothing but, electrochemical cell. Okay, electrochemical cell. So we study this in chemistry also regarding electrochemical cell. So this electrochemical cell will be utilized in this circuits. Okay, so now we will see a little bit about electrochemical cell, what is happening inside. Then we will get a proper understanding on the remaining things like internal resistance. Okay, what is electromotive force, all these things we will see. So electrochemical cell. Okay, so in electrochemical cell, what it does, chemical energy will be converted into what? Electrical energy. Okay, in electrochemical cell, chemical energy will be converted into electrical energy. Suppose if we draw, okay, if you draw an electrochemical cell, okay, it will have two electrodes like this, okay, right. Now see, from one electrode I am making a connection and I am drawing the resistance also here. So outside in this, you can see in this figure you can see a resistance here. This resistance is what I am drawing here. Now these electrodes, it is dipped in what? Dipped in electrolyte, okay, right. So this is nothing but a conducting solution, okay. This electrolyte is nothing but a conducting solution. This is a conducting solution and here we have electrolyte, correct, and these two are what? Electrodes. So so when we dip some particular electrodes in some particular electrolyte, not all the electrodes and all the electrolytes, some particular, that you might have studied in chemistry. So electrolyte can be, okay, electrolyte can be what? Zinc sulfate, okay, zinc sulfate or copper sulfate, okay, anything like this, okay. There are some specific solutions whose properties will be making us to use them as electrolytes. So this is the setup, electrochemical cell setup. So what happens when we dip this electrode into electrolyte, okay, with this setup, what will happen? Chemical reaction will happen, okay. So when chemical reaction occurs, chemical reaction occurs, it will liberate energy, it will liberate energy. That energy will be utilized as utilized in the circuits, okay. They will be this chemical reaction happens and chemical energy will be converted into electrical energy. This is what is happening in an electrochemical cell. Suppose if two electrodes like this, when it is dipped in electrolyte, oxidation, you have studied, oxidation happens in one electrode, okay, and reduction happens in another. So we can say overall redox reaction happens. Redox reaction happens here, okay. So both of them putting together, redox reaction is what is happening. So at into one electrode, negative charges will be accumulated and into the another electrode, positive charges will be accumulated. So where these negative charges are accumulated, it is called anode, and where positive charges will be accumulated, that is called cathode, okay. So where in anode what is happening? Oxidation happens in anode and reduction happens in cathode. So this is the thing. So anode becomes negative because of this collection of negatively charged particle there, and at cathode becomes positively charged electron, okay. So what happens? This anode where negatively charged particles came together, that will become at a negative potential, okay. Anode will become at this anode will become what? Negative potential, negative potential, and cathode will become positive potential. Clear or what? Okay, so when chemical reaction happens, when we dip these electrodes in the electrolyte, what happens? Negatively charged particles will go to anode and positively charged particle will be going to cathode. So negatively charged particle wherever it is concentrated in anode, oxidation happens there. Okay, so there negatively charged particles, when they accumulate, that will become negative potential, and wherever positively charged particles are going because of reduction reaction, there that will become positive potential. Okay, so here at anode we can say here excess of electrons, and the other side cathode there will be deficiency of electrons, so this is how this activity works. Now we will come to the full picture and we will explain. Okay, suppose this is a cell, one electrode which is anode, another is cathode. So we have connected our resistance also into this. Now electrolyte is there. Okay, so at one terminal, what, where anode is there, where electrons will be joined together, and wherever cathode is there, we will be getting positive charges. Okay, so this is what is happening. Now from where, which terminal to another terminal, which terminal to which terminal, here it is nothing but electrons. We can ask like from which electrode to which electrode electrons will flow. Okay, from there will be excess of electrons at what, anode, excess of electrons here, excess of electrons. At cathode there is deficiency of electrons. So what happens, electrons will be flowing from anode to cathode. Electrons will be flowing from anode to cathode, and so what happens, current will be flowing from cathode to anode. Current will be flowing from cathode to anode. Okay, now when electron reaches cathode, see electron is coming. Now what happens is electrons reach the cathode. Now from cathode to anode, how electrons will glow? Electrons must go, then only there will be a closed circuit. Current will form only in closed circuit. If a circuit is not closed, okay, current will flow only in a closed circuit. Correct? No? If there is no closed circuit, okay, if there is no closed circuit, current will not flow. Correct or what? So here current will flow. Suppose if we open a circuit, no current will flow. So the electrons, when they came to cathode, how it will be going to anode? Okay, because electrons will be attracted to positively charged particles. So cathode is positive, so electrons will be there at cathode. Now what happens here? Because electrons will be attracted to cathode, electrons will be attracted to cathode. Okay, and what force it is? It is nothing but electrostatic force. Electrostatic force. Now electron must go to anode, then only this closed path will happen, and that will happen also, that is happening also. Okay, electrons will go. So this is nothing but the battery mechanism. Okay, this is called battery mechanism. Okay, electrons will flow from cathode to anode. Okay, so this cathode is at a negative charge and anode is having positive charge due to, we call them battery mechanism. Okay, so this is done by the electrochemical reaction. Okay, so what happens is exothermic exothermic chemical reaction happens. Exothermic chemical reaction happens there. This will provide energy. This will provide energy to electrons, okay, to move from cathode to anode. Clear or what? Okay, so this exothermic chemical reaction will provide energy for electrons to move from cathode to anode. That is, they will do, someone will do the work on electrons. Okay, someone does work on electrons to move from cathode to anode. Who does this work? That will be done by the exothermic chemical reaction, that is called a battery mechanism. Okay, this is called a battery mechanism, we can say. Okay, so we can, in short, we can say electrons gets energy from chemical reaction against against electrostatic force, against electrostatic force, we can say, because electrostatic force is their force of attraction on electron by cathode, because cathode is positively charged. So that will be there, but this energy from this chemical reaction will drive electrons to move from cathode to anode. Okay, so one thing we can infer here, like which is at a higher potential and which is at a lower potential. So wherever negative charges are there, that we call anode, and wherever positive charges are there, that is called cathode. So electron is moving inside the battery. Outside the battery, electron was moving from uh, positive terminal to negative terminal, or we can say from higher potential to lower potential outside the battery. Inside the battery, the same cathode is nothing but, that is at a what potential? Cathode is at a higher potential. Cathode is at a higher potential and anode is at a lower potential. Okay, so current flows from higher potential to lower potential. Now I am telling about electrons outside the battery. Okay, electrons move from lower potential to higher potential. Outside the battery, electrons move from lower potential to higher potential. Outside the battery, current moves from higher potential to lower potential. But inside the battery means the two electrons that is dipped inside the electrolyte. So inside the electrolyte, we can see electron is moving from where to where? From higher potential to lower potential, exactly opposite of what is happening outside. Electron is moving from higher potential to lower potential, and current is moving from lower potential to higher potential. So this is an important point, you must note this. Okay, okay, outside the battery, outside the battery, current, okay, current flows from higher potential. Higher potential is positively charged. So we can say this is nothing but which electrode, which terminal, that is nothing but cathode. Higher potential to lower potential. So lower potential is nothing but here anode. Under cathode, what can we write? Whether they are positively charged or negatively charged. Cathode, here it is positive charge. Anode is now negatively charged. And inside the battery, okay, regarding electron also we will note electrons flow from, okay, lower potential, which is nothing but anode, okay, negative to higher potential. Higher potential. So higher potential is nothing but cathode. Okay, it should not get confusion. That is why I am writing again. So this is regarding outside the battery. Now we will see what is happening inside. Okay, inside the battery. So current, okay, from lower potential to higher potential, lower to higher potential. So lower means what is anode? That is nothing but negative. Higher potential means cathode, which is nothing but positive. What about electron? Electron flows from higher to lower. Okay, so higher is cathode again, lower is anode. Okay, so theoretical questions, conceptual theoretical questions, if they ask putting this concept in front of you, okay, you can answer it clearly. Okay, now this is what is happening inside. Now when we take an electrode, okay, this is positive and this is negative. So there will be force. If an electron is there, there will be an electrostatic force, okay, Fe. I have noted Fe, that will be towards cathode, that is positive. And battery force, there will be a battery force due to battery mechanism. This force is provided by the chemical reaction happening inside the cell, that will be happening towards anode, on electron, if we consider electron, okay, we can say, okay, F electrostatic is happening towards, okay, positive terminal, and Fb, okay, battery force is happening towards the negative terminal, and Fb is very much greater than F electrostatic, and so definitely what will happen, electrons will be flowing towards negatively charged terminal, that is anode. Okay, so this is due to what? Due to exothermic redox reaction. Okay, are you clear about what is happening inside the cell, outside the cell, how electrons are moving, all these mechanisms you understood? And again, regarding more about electrochemical cell, you will be studying in chemistry. Okay, so that is not the discussion here. Now we will get into EMF, nothing but electromotive force. Electromotive force, or we can say EMF. So this name EMF came due to historical reasons. Okay, this is not actually force. So people who were studying about this previously, much before, they thought that some force is behind these electrons or charged particle to move around the circuit, and they saw very clear reasons also, that is nothing but the battery force which we have discussed. So because of all this battery force and all, they named the phenomenon, okay, the reason behind the movement of charges, as force, electromotive force. But electromotive force is not a force because they are actually not the force, actually the potential difference which is causing the real movement of electrons and the current. So we can say the clear definition is nothing but, okay, electromotive force is the potential difference, okay, difference between potential difference between two electrodes, okay, potential difference between two electrodes or terminals of a cell when no current is flowing, when no current is flowing, when no current is flowing, in bracket you can write open circuit, okay, open circuit. So EMF is the potential difference across two terminals of a cell when no current is flowing. So we name this as electromotive force, but its unit is not Newton. Okay, I already said this is the potential difference. So unit of EMF is volt. Okay, not Newton. Clear or what? Right. Its symbol is the symbol of EMF. Okay, symbol of EMF is nothing but this is the symbol E. Okay, clear or what? So this electromotive force is the potential difference between two terminals of a cell when no current flows, or we can say when the battery is not in use. Okay, EMF is the EMF is the potential difference, okay, across terminals of a cell when the battery is off or not in use. Okay, so now we will see like how this makes the difference by seeing the diagram and all. Okay, so another way we can say this electromotive force E is nothing but, okay, standard reduction potential, okay, V plus minus V minus of V minus, okay, or we can say V plus plus V minus. This is nothing but the standard reduction potential and standard oxidation potential. Okay, you have studied in chemistry. Say for example, I will show using electrodes. Suppose, okay, if this negatively charged electrode, negatively charged electron, when we say its potential, we will be saying -3 or -4 or -5, something like that. So here the magnitude is 3, but we can say its sign is nothing but minus because it is at a negative potential. A positively charged potential, suppose if it is at 6 volt, then EMF is nothing but V plus or standard uh, oxidation potential and standard reduction potential. So plus is nothing but reduction potential. So 6 volt minus of minus 3 volt. So if we write that 6 plus 3 is going to be 9 volt. So we can say EMF is nothing but when we write V plus plus V minus. So V plus is nothing but standard reduction potential and V minus is nothing but standard oxidation potential, which you are studying in chemistry. Just for your understanding, I am saying this is nothing but the potential difference between the potential of two electrodes. So here we will get 9 volt as the EMF. This is how we need to calculate EMF inside the cell if we get values in the electrodes. Now suppose just we will take an experiment. Say for example, if I connect a resistance to a cell and the EMF of the cell is given as 9 volt, which we have seen like how this 9 volt is measured. Now if the resistance is 2 ohm, okay, and if I connect an ammeter in the circuit to measure the current, I connected an ammeter and I connected a voltmeter to measure the voltage across 2 ohm resistance. Why we connect ammeter? We will study regarding ammeter and voltmeter in detail in this chapter. Now we just need to understand that ammeter is a measuring device. So if we connect them in the circuit, it will measure current and it will give us the value like a 2 ampere. The reading will be shown. Then voltmeter, voltage we will be measuring. Suppose if this is a resistance, voltmeter we connect across parallelly just to understand the voltage difference across two terminals. So we connected a voltmeter and we connected an ammeter. Okay, so EMF is 9 volt and resistance is 2 ohm. Now can you tell me what is the value of current in the circuit? So if we try to measure current, okay, I is equal to E by R. So E is nothing but 9 volt, R is nothing but 2 ohm. We will be getting 4.5 ampere as the current. So 4.5 ampere, here it is going 4.5 ampere. Likewise 4.5 ampere, it goes like that. So this is the current. Now what is the voltage across this 2 ohm? 4.5 ampere is flowing across 2 ohm. So voltage across 2 ohm is nothing but this is IR. So 4.5 into resistance 2, we will be getting 9 volt. So 9 voltage drop must be there in the 2 volt. Now fine. This is how the theoretical reading is coming. Now what we do? Really if we connect a circuit and if we measure this, we are observation, okay? Observation, we connected this circuit and we are taking the observation. So theoretical value is this must be the answer. So suppose if we take a meter reading, it is showing just 3 amperes. When we take voltmeter reading, it is showing 6 volt. So this is shocking. What happened to that 3 volt? Who took that 3 volt? Okay, who ate that 3 volt? Where that 3 volt has gone? Okay, so something is missing here. Okay, so when we take the real reading, this is what is happening. Now we need to understand one person is hiding in this circuit. Okay, one person, important person is hiding in this circuit. That person has taken this 3 volt. And who is that? That is nothing but internal resistance. Okay, internal resistance. Now we'll discuss about internal resistance of a cell. Internal resistance of a cell. So this resistance is hiding in the circuit. Okay, this is nothing but the resistance inside the battery. Okay, there is a resistance inside the battery. Just like if we mark this terminal, no, this is positive terminal, this is negative terminal, this is how we mark. Suppose if there is a resistance, small resistance inside the cell, if you mark like this, okay, because this resistance is inside. Now drawing this resistance inside the cell, then marking all this, our predecessors, our ancestors, they didn't feel good. So what they started is they will start drawing internal resistance just adjacent to the negative terminal, okay, or lower potential, just they will mark, and usually that will be denoted as small r. So what is internal resistance? Okay, we will write the resistance offered by material of electrolyte, okay, material of electrolyte to the flow of current inside the cell. Okay, so electrolyte is there. We know electrons move from cathode to anode. Electrons move from cathode to anode just with the help of that redox reaction. Okay, exothermic redox reaction will help the electron. The exothermic redox reaction will work on the electrons, and then they will bring from cathode to anode. Okay, they will do that. Now while doing this, there are lot of anions, cations in the electrolyte. Okay, these electrons will have to collide with them. So say for the same case with the positively charged particles also. So all those resistance created by the material inside the electrolyte to the flow of current is what? Internal resistance. So this internal resistance we will mark just adjacent to the negative terminal. Okay, so this is by the collision with the particles. Okay, the same way these electrons will experience some collisions where also in the circuit also same way they will experience some collisions inside the electrolyte also. So when we if we redraw the circuit, okay, this is resistance. What was the resistance value? 2 ohm. Now it was 9 volt, and we mark the small internal resistance also. Suppose if internal resistance is 1 ohm, okay, small r is equal to 1 ohm, capital R is 2 ohm. Now let us check what is the equivalent resistance. So one thing is always internal resistance is series to the external circuit. Okay, internal resistance is always, okay, in series with the external circuit. Right. So R equivalent is nothing but capital R plus small r, they are in series. So this is nothing but 2 plus 1, this is equal to 3 ohm. Now suppose now if we try to calculate the current E by R equivalent, we will be getting 9 volt divided by 3, we will be getting 3 ampere current. See, in the previous case somewhere something was missing. Ammeter reading was 3 ampere, theoretical value was 1.5 ampere. We were worrying like where this 1.5 has gone. Okay, now 3 ampere it is coming correctly when we consider the internal resistance. Same way if we try to take the voltage value across 2 ohm, this is equal to I into 2, resistance 2 ohm. So 3 into 2 we are getting 6 volt. Clear or what? Hope you understood. Okay, so now when internal resistance comes, all the values have changed. Who has taken that 3 volt, everything came into picture. Clear or what? Okay, so now we see this 9 volt is there. This 9 volt, when current 3 ampere flows here, current flows from higher potential to lower potential. So when I mark current in the resistance, I mark positive in the beginning, negative at the other end, just to show that current is moving from positive terminal to negative terminal. This sign convention will help me while solving Kirchhoff's law and all. We will see in the coming lectures. Okay, so 3 ampere is flowing like this. So this is going to be V is equal to IR, if we do, this is 3 into 2, we will be getting 6 volt. So 6 volt is dropped here in 2 ohm, and here if this 3 ampere is coming, 3 ampere is coming, this 3 into 3 volt into 1 ohm, we are getting what here? 3 volt. So look here, this 9 volt is dropped as 6 volt in the 2 ohm, and this 3 volt in the 1 ohm. So entire 9 volt is distributed among the resistors. Clear or what? Okay, fine. So now we will discuss now. Oh, see, E was electromotive force, and 9 volt was the electromotive force. Now if we consider that 1 ohm resistance, then whatever is consumed by this 1 ohm internal resistance, this 1 ohm internal resistance is just an example. It could be 0.5 ohm or 0.25 ohm, 0.1 ohm, any value, okay, any small value generally. So remaining voltage is distributed at a external resistance R, that is called a terminal voltage. Previously when we were defining about electromotive force, we said that is the voltage across the cell, okay, voltage across the cell, okay, or voltage across the circuit when no current is flowing, okay, when we said when battery is not in use. So now when the battery is in use, okay, when current starts flowing, external circuit or external resistance will take some voltage, that is called a terminal voltage. Now we will look into that. Okay, so terminal voltage, or we can say terminal potential difference. Terminal potential difference. Okay, terminal voltage or terminal potential difference. So we can say potential difference, potential difference across the terminals of a cell, okay, of a cell when current is drawn from cell. Okay, that is when current is flowing. Previously, what is EMF? See the difference. Okay, electromotive force or EMF is the potential difference between two electrodes or terminals of a cell when no current is flowing, that is open circuit. Now this one is potential difference across the same terminals across the cell when current is drawn from the cell. Now we must have a clarity that already we have studied about internal resistance, and when we draw internal resistance, which one is the two terminals? Either this one and this one, or here, or in between. Before we should consider internal resistance or not? We should consider internal resistance. So when I mark these highlighted 2 points, this is what is called a terminal of a cell. Okay, this is called the terminals of a cell. This is positive and this one is negative. Okay, so terminal voltage is nothing but, or terminal potential difference is the potential difference sorry, across the terminals of a cell when current is drawn from the cell. Another definition, same result we will be getting for everything, but another definition is potential difference, okay, across external circuit. That is also correct. That is terminal voltage or terminal potential difference. Okay, this is also fine. Potential difference across external circuit. Okay, terminal voltage. Clear? So here in the previous case, okay, in this circuit, whatever voltage we got in the external resistance R, that is what is terminal potential difference. So you can see here, now we got 6 volt now. 6 volt was nothing but 9 volt minus 3 volt. So if we consider 6 volt, this is nothing but terminal voltage. And what is this 9 volt? 9 volt is nothing but the EMF. Okay, when no current is flowing, this is the EMF. So we can say this is nothing but EMF. I write the symbol. What is this 3 volt? 3 volt was nothing but 3 ampere into 1 ohm. 1 ohm is the internal resistance and 3 ampere was the current flowing. So I can write like a terminal voltage. If I write V suffix T, it can be denoted like V also. Okay, this is equal to the EMF E minus the current into small resistance, internal resistance R. So this is the formula for finding terminal potential difference. Okay, Vt is equal to E minus IR. Clear? All of you understood? Okay, so now clear or what? Okay, fine. So we will see the derivation also. Derivation of V is equal to E minus IR. That is the derivation of, this is not suffix actually. We should not feel like that. This is E minus IR. Okay. Suppose if we consider a battery. Okay, so this is plus, this is minus. This is nothing but higher potential, and this side it is nothing but lower potential. So near to lower potential we will mark our internal resistance R also. Suppose if we connect an external circuit, okay, external circuit like this, okay, external circuit like this, the current flows like this from positive terminal to negative terminal. So this is how the current flows. Now we need to find the potential across two terminals of a battery. So two terminals of a battery here, two terminals of a battery is same as the two terminals of external resistance also, okay, or external circuitry, both are same. Now suppose if we consider one end as A, another end as B. So potential at B we will consider as VB, and potential at A we will consider as VA. Now, suppose if current is flowing, current will be flowing from higher potential to lower potential. So even in uh, resistance also, when current is flowing, you might be remembering I just marked plus and minus. So higher potential we take as plus, lower potential we take as minus. So VB will be at plus, VA is at a lower potential. Why? Because current is flowing in that direction. So VA I am going to take as negative. Okay, now we will choose this path. Okay, to analyze we are going to choose this path in the direction of current. So VB, okay, VB, then current is coming, value of current is I. Okay, so VB minus, okay, potential at VB minus current I into R. Okay, then next is lower potential first, then higher potential. So minus E, okay, minus E, sorry, there we should put plus because higher potential is coming next. Okay, first see, when we choose the sign, put the sign in the direction of current, plus minus. Okay, so this is a sign convention. Okay, we will discuss this in detail in Kirchhoff's law, Kirchhoff's current law, voltage law. We will going to discuss in detail. But here also, just I am giving an introduction. In the direction of current, mark the sign plus minus for resistors. Anyway, for battery for a cell, already the terminals will be marked there, but higher potential we will take as positive, lower potential we will be taking as negative. So choose the second sign we are putting for anything. So VB plus minus IR, then plus E, okay, plus E, then minus VA is equal to 0. Okay, so whatever potential is there across all the elements, if we put in the correct sign, everything will become 0, because whatever potential is there from the battery, those potential will be divided across the resistance. So sum of all the potential of a loop, if we take, that will become 0. Now here we are considering the terminals between A and B alone. So we can say E minus IR is equal to VA minus VB. So that is nothing but potential difference, potential difference across terminals of a cell, terminals of cell. Okay, when current is drawn, when current is drawn. Clear or what? So E minus IR is VA minus VB. In short, we can write like E minus IR is equal to the terminal potential difference. Clear? Understood or not? Okay. Or another formula we can write is nothing but terminal potential difference is nothing but the current that is flowing in the circuit into external resistance. External resistance. So this external resistance need not be a single resistance. If two resistances are there in series, we should consider them their addition, R1 plus R2. If they are in parallel, we need to take the equivalent resistance. So this external resistance is nothing but R equivalent. Okay, R equivalent of what? Without considering the internal resistance. Okay, this is what is terminal potential difference. Now we will do a problem. Okay, look at this question, students. A car has a fresh storage battery of EMF 12 volt and internal resistance 5 into 10 raised to minus 2. Okay, just 0.05 ohm. If the starter motor draws a current of 90 ampere, that means that current is flowing. What is the terminal voltage of the battery when the starter is on? Just an introductory question, very easy one. Okay, just pause and do yourself, then verify the answer here, note it down. Okay, this is the question. Okay, so just direct application we can do. So do this. Okay, so EMF is what? EMF is given 12 volt, internal resistance is given 5 into 10 raised to minus 2 ohm, and the current is also there, that is nothing but 90 ampere. Okay, so we need to find the terminal voltage. So terminal voltage is what? E minus I into R, EMF minus I into R, or otherwise that current into the external resistance. So external resistance is not given in the question, so E minus IR we can do. Okay, correct. So E is nothing but 12 volt minus I is nothing but 90 into 5 into 10 raised to minus 2, right? So if you do this, we will be getting this as 4.5. 12 minus 4.5, their answer is going to be 7.5 volt. Option B. Clear? Understood or not? So this is just an introduction about the cell. We discussed about cell, then internal resistance, then how the working of cell internally, just to understand that how the flow of electrons and what is the reason of that, and whether the flow of current is from higher potential to lower potential outwards, internally inside the cell from lower potential to higher potential. Okay, current is flowing from lower potential to higher potential inside the cell. Generally, general statement is what? Current flows from higher potential to lower potential. Even me, I have told this also in the class. But that is a what? Across the circuit outside the cell. Inside the cell, if we consider, things will be in the opposite way. Just to understand that, we have discussed all that. Clear or what? Then, what is EMF? EMF is nothing but the potential difference of two terminals of a cell when no current is flowing across the cell. That is nothing but E. Okay, E, whatever is given. What is terminal voltage? Terminal voltage is the voltage across the terminals of a cell when current is flowing. Okay, when the circuit is on. Clear? Then internal resistance is there, that is nothing but the resistance offered by the electrolyte of the cell. The resistance inside the battery. Okay, so that, in order to consider that, we will draw as a resistance and we will keep it adjacent to the negative terminal of the cell. Okay, so terminal potential difference, EMF, internal resistance, all this introduction is done. Okay, we will continue in the next class. So keep studying, students. Thank you. Bye bye. Good luck.